Mega-tsunamis in an ancient ocean on Mars may have shaped the landscape and left deposits that hint at whether the planet was once habitable, researchers say. The giant waves, thought to have reached up to 120 meters in height as they raced over the land, could have been triggered by two large meteorites slamming into the surface. The tsunamis may have been powerful enough to shape much of the ancient coastlines on Mars, said J. Alexis Palmero Rodriguez of the Planetary Science Institute in Tucson, Arizona, who led the study. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. Writing in the journal Scientific Reports, the international team, which included scientists from the US, China, and Germany, describe how they set out to probe a Martian mystery. It has previously been proposed that the lowlands of the northern hemisphere of Mars were catastrophically flooded around 3.4 billion years ago, forming a vast ocean, potentially covering several million square kilometers. But scientists have been puzzled by the lack of an associated shoreline and its expected features. Now Rodriguez and his team think they may have the answer. The fact that it is hard to make out such ancient shorelines is because huge tsunamis buried them, depositing sediments up to hundreds of kilometers inland. The scientists believe the deposits are the remnants of two tsunamis that rushed over the Martian landscape, burying the ancient shoreline. Computer simulations, adds Rodriguez, suggest that such tsunamis could have been generated by large impacts, generating waves with an average height onshore of 50 meters, with the largest reaching 120 meters. We link the origin of the tsunamis to meteorite impacts that produced craters 30 kilometers in diameter, he said, adding that such impacts occurred over the whole ocean around once every 3 million years. On our planet, earthquake-triggered tsunamis can be catastrophic. But on Mars, meteor strikes may have generated tsunamis 10 times larger than anything seen here, behemoth waves of destruction capable of submerging the Statue of Liberty and the Capitol building. The Mega-Tsunamis would have occurred about 3.4 billion years ago, when two large space rocks slammed into a chilly sea in the Martian north. The first of these impacts, according to a study published this week in Scientific Reports, spawned massive, nearly 400-foot-tall waves that carried bus-sized boulders many miles inland. The waves flooded more than 220,000 square miles, an area larger than many U.S. states. The next impact, which would have occurred some several million years later, met a Mars that was a bit chillier. Instead of smashing into a watery sea, the meteor collided with a frozen ocean, and instead of flooding the Martian plains and then draining away, those slushy waves spread inland and stuck. Today, evidence for these ancient cataclysms takes the form of channels carved by the receding waves, lobe-shaped fields strewn with boulders, and craters that appear to have been filled with now evaporated seawater, says study co-author Alexis Rodriguez of the Planetary Science Institute in Arizona. It's an interesting story that is consistent with observations gathered by various spacecraft orbiting Mars. I think they've done a very nice job of pulling together a story that is self-consistent and well justified by the evidence they highlight, says Cornell University's Don Banfield. No ocean, no tsunami. But Banfield and others say some persnickety details need sorting out before the tale becomes established fact. First and most important, to have a tsunami, you need an ocean. And it's not clear whether Mars had a northern ocean during the late Hesperian, the period about 3.4 billion years ago, when Rodriguez and his colleagues suggest these tsunamis occurred. There's strong evidence that water once flowed on the red planet. It left its fingerprints in the valley networks and outflow channels carved into the Martian surface. But those features formed in the Noachian period and so are about 3.8 billion years old, meaning they existed before scientists think Mars lost most of its insulating, water-friendly atmosphere. As that atmosphere faded away and the planet chilled, its ability to preserve liquid water on its surface evaporated. But there's a lot we don't know about Mars's ancient climate, so though oceans may have sloshed around at one point, it's not clear whether large bodies of water persisted through the Hesperian. By this point, Mars's atmosphere had probably eroded significantly compared to the late Noachian, which is when we have the most evidence of erosion by liquid water, says Harvard University's Robin Wordsworth. That's not necessarily a problem, Rodriguez says. A transient sea could have existed later in Mars's life, perhaps an extremely salty one that resisted freezing. And even if a meteor smashed into an ice-capped ocean, it could still generate a tsunami. But more work is needed to figure out exactly how that would work. Finding well-preserved shorelines would help back up the idea of oceans on ancient Mars. But that kind of evidence has also been tough to pin down. The idea of an ocean is not beyond the realm of possibility, says Joel Davis of University College London. However, much of the geology in the northern lowlands has since been obscured by younger material or eroded, so it's difficult to find much direct evidence of a past ocean. Banfield agrees. The search for characteristic shorelines of ancient seas on Mars has been tough going. Some believe they found some, others identify problems with these putative shorelines. But Rodriguez and his colleagues think their work offers an explanation for why that shoreline is absent. It's been erased and modified by the Mega-Tsunamis that soaked the planet as meteors pummeled Mars during the Hesperian. If there was an ocean, tsunamis are a good explanation for why we don't see much of any shoreline, says Wordsworth. Glacial alternative. Some scientists say it's still possible to explain the tsunami-linked features in ways that don't invoke ancient cataclysms. Glacial transport, for instance, could have created some of those boulder fields, says Edwin Kite of the University of Chicago. Bouldery debris is found on top of and at the margins of glaciers on Mars, and there is evidence for past glaciation and present-day debris-mantled ice along the Deuteronomus Mensae, Kite says, referencing the Martian region being studied. Rodriguez counters that it's unlikely anything else could explain the flows his team observed, which move uphill and flow around small obstacles in ways glaciers wouldn't. And Brian Hynek, of the University of Colorado Boulder, agrees that the tsunami hypothesis is the best explanation for the observations. We had lots of glacial activity at Mars elsewhere through time, and these large-scale features, backwash channels, and streamlined bars with very large boulders are not found in other glacially modified landscapes, Hynek says. Ephemeral fingerprints. The reality is that even on Earth it can be incredibly difficult to point to landforms and prove they were the work of a swollen sea. It takes a very particular type of coastline to leave behind the unmistakable signature of a tsunami in the first place, says Ricardo Romaglio of the University of Bristol. The coastline has to have the right characteristics for sizable deposits to be produced. You need a reef or cliff to produce large boulders, for example, Romaglio says. And this, of course, cannot be safely established in the case of Mars. Evidence of recent earthly tsunamis, such as the ones triggered by the 2004 and 2011 earthquakes off the Indonesian and Japanese coasts, is already vanishing, says Pedro Costa of the University of Lisbon. Mars does a better job of preserving its history than does Earth, where tectonic activity and other processes are continually erasing the fingerprints of past events. But ultimately, only more observations, such as identifying transported ocean sediments, could help convincingly prove that Mega-Tsunamis sculpted the Martian landscape. I hope that the story is true and can prove the ancient ocean hypothesis, because that would be very exciting, says Francois Forget of the University of Paris. But I know that more work is needed to confirm the scenario. This is how science works.